Please welcome to the stage Dr. Tanishq Abraham, Research Director at Stability AI.
Hello, everyone. Yep, really excited to be here. And I want to start out by asking you all a question. What if I could tell you exactly what you're picturing in your mind? Whether it may be some sort of childhood home or a favorite dream, or maybe it's just an idea that you've been trying to put into words but just can't quite explain. Does this sound like science fiction to you? Perhaps not. We're right now standing at the threshold of making mind reading a reality, and unlike what you might expect, no surgery required. You may have heard of remarkable technologies like Neuralink, which require implantation of electrodes directly onto the brain. But the holy grail is non-invasive mind reading, which doesn't require any access or modification to the brain. One promising avenue for non-invasive mind reading is the utilization of fMRI brain scans of patients. fMRI is a variant of MRI, which instead measures blood flow of the brain, which correlates with which regions of the brain is active. Essentially, it's a very sophisticated camera for brain activity. So the question is, can we use this picture of brain activity and correspond that with your thoughts? Research over the past decade has suggested that it can be done with the utilization of machine learning, as you can see here. But in 2022, we witnessed the explosion of generative AI technology. And generative AI has enabled incredible feats like generating extremely realistic images from text descriptions. So at that moment, something clicked. If generative AI can turn words into beautiful images, could it do the same with brain activity patterns and your thoughts? In 2023, near the end of my Ph.D., I founded MedARC, a research organization focused on applying generative AI to medicine. At MedARC, we decided to take a crack at this mind-reading problem. We brought together a team of very talented researchers from institutions like Princeton and University of Toronto, and led by my colleague, Dr. Paul Scotty, a very experienced neuroscientist. And we utilized some of the best image generation AIs and applied it to a brand new, very high-quality fMRI dataset. And this enabled us to create our mind-reading AI, which we call MindEye. Think of it as a translator between the language of brain activity and the language of images. So let me show you what this means. So this is our MindEye, the results of our MindEye technology. And you can see we have these volunteers that have their brain scanned while they're looking at a variety of images. So on the left-hand side, on the left column, you can see the images that they're looking at while their brains are being scanned. And on the right column, these are the reconstructions from our AI. And the AI is only using the brain activity to produce these reconstructions, our mind-reading AI. And as you can see, this is a significant leap compared to the previous results that other teams have reported. And the accuracy is just unprecedented. You can see how incredible, how close the reconstructions are to the actual images that the people were looking at. So how does this actually work? The overall approach is actually quite simple. Generative neural networks speak and understand an intermediate language that we teach them known as embeddings. And this allows them to process images and text. And so all of these image generation AIs that you may have heard of, like Midjourney and Stable Diffusion, which is a product of Stability AI, the company that I work at, all of these image generation AIs, they have embeddings that they've already learned how to understand, and that allow them to be able to understand images and generate images. So what we want to do is we want to be able to have embeddings that come from the fMRI brain scans. So we train a translator AI that is able to translate from the fMRI brain scans to these embeddings. And now we have fMRI-derived embeddings. And these fMRI-derived embeddings can be passed into the image generation AI and generate the images that correspond to the brain scans. And that's basically it. Of course, there are some challenges and limitations with MindEye, which we're now working on further expanding MindEye to resolve these limitations. So let me go through some of these limitations and how we're resolving them. So the first limitation is the fact that everybody's brain is very unique. And so what this means is that we need to actually train a new translator AI for each person. And this used to require 40 hours of brain scan data. But we've actually brought it down to 1 hour of data with significant innovations. And the way we do that is that we actually train a shared translator AI. So we try to train an AI that is supposed to work for all brains. But the problem is that, again, each brain is unique, so it's not going to be perfect for every brain. So we actually utilize 1 hour of fMRI brain scan data to further calibrate that for every new person. And so that's how we use that extra 1 hour of data. And we're now further researching ways to bring that amount even down further. Another challenge is that right now we're only focusing on what the person is looking at and how they're perceiving it. So you see that they're looking at an image and we're reconstructing what they're perceiving. But the next step is to reconstruct and determine what a person is imagining in their head. And this is known as mental imagery. And research suggests that the brain utilizes similar regions for visual perception and mental imagery. So it should be feasible to utilize MindEye for mental imagery as well. And in fact, we have some very promising results in this area of trying to utilize MindEye for mental imagery, and we will be sharing and publishing those results very soon in the next coming months. So stay tuned to hear more about that soon. Finally, we are taking brain scans with an MRI machine. And MRI machines are not very portable, as you may have experienced yourselves, and they're also very expensive. So this may seem like a huge limitation, but thankfully there are new brain-computer interfaces and neuroimaging techniques that are on the horizon, and at this point it's more of an engineering challenge to make them portable and cheaper. But the most important part is that the overall approach of MindEye should still work. The sort of general approach of translating from a language of brain activity, depending on whatever method it comes from, but this language of brain activity, translating it from this language of brain activity to the language of either an image generation AI or maybe other types of AIs, like text generation AIs or audio generation AIs. So overall, while truly capable, portable, non-invasive mind reading is still many years away, there is significant promise in the current technologies and trying to further develop and advance these current technologies in achieving this holy grail of non-invasive mind reading. So, if we are able to develop this holy grail of non-invasive mind reading, what are the possibilities that this enables? Personally, I'm quite excited by the potential clinical applications. We could study how mental illness affects cognition as reflected in the reconstructions of visual perception and mental imagery. And we could utilize this to develop better diagnostics and treatment for mental illness. For example, in a depressed patient, you could imagine that they spend more time and more attention focusing on negative aspects of an image. And this would be reflected in the reconstructions of visual perception and mental imagery. So we would potentially see that in the AI-generated reconstructions from their brain. And we could also observe how these reconstructions change over the course of treatment and utilize that to inform and improve and personalize treatment for these depressed patients or mental health patients in general. So this is one really promising avenue of research and application for these sorts of technologies. Another promising application, really exciting application, is the sorts of new forms of communication and expression that this technology could enable. From being able to record your favorite memories or dreams, to being able to artistically express your imagination in new ways. The possibilities are endless. In conclusion, we stand at a fascinating intersection between neuroscience and artificial intelligence. And through recent advances in generative AI and neuroimaging, we are now able to decode the mind in ways that were previously confined to science fiction. MindEye represents a significant breakthrough in the ability to translate brain activity to reconstruction of visual perception. But it is just the beginning of a much larger journey. Numerous challenges remain, as we just discussed, but the potential applications from revolutionizing mental health diagnosis and treatment to enabling new forms of communication, this will fundamentally transform how we interact and understand human cognition. Every significant leap in human communication, from the written word to photos to the internet, has fundamentally transformed society. And mind-reading technology will not just change the way we communicate with each other, but change how we understand ourselves and each other. This is more than just a technological revolution. This is a revolution in human communication. And it's not just coming, it's already beginning. Thank you.